Hello dear students, let us study the series and parallel connection. Here we will introduce regarding series and parallel connection and how series and parallel connections are differentiated. Let us take R1 and R2 be the two resistors. I am taking R1 resistor and I am connecting this one end of the R1 with the other end of the resistor R2, and this is R2. The one end of the resistor R1 is connected to the one end of the battery. We know that battery has two terminals, that is positive and negative. Bigger terminal is known as positive terminal and smaller end is negative terminal, and I am connecting this to the switch, and the switch is connected to the resistor R2. We know that the current always flows from positive terminal of the battery to the negative terminal of the battery, and the current is flowing in the clockwise direction. In this circuit, we know that the across R1 we are having potential difference V1, and across R2 we are having potential difference V2, and this the potential differences are measured with the help of voltmeter. We know that in a series the electric current remains constant, that is the current across R1 and R2 are constant, that is I is equal to I1 is equal to I2, but the potential difference varies, that is V is not equal to V1 is not equal to V2, that is V is equal to what? V1 plus V2. If we add V1 and V2, we will get V1 plus V2. Now the effective resistance in series is given by RS is equal to R1 plus R2. If there are more than two resistors are there, then RS is equal to, that is combined resistance is equal to R1 plus R2 plus R3 plus so on plus Rn. Let us see the next type of connection, that is parallel connection. Let us see how this connection is made. I am taking one wire of the electric circuit, and I am taking one resistor R1, and I am taking one more resistor R2. The one end of the resistor R1 is connected to the one point of the wire, and other end of the R2 is connected to the one terminal of the wire. I am taking the other end of the resistor R1 and I am connecting to the main wire, and I am taking other end of the resistor R2 and I am connecting it to the other main wire. Now I am connecting the ends of the wire with the battery to the positive terminal of the battery and one to the negative terminal of the battery, and in between I am connecting a switch. Now the current will always flow from the positive terminal of the battery to the negative terminal of the battery. We know that the current across the parallel connection is changing, that is varies. Current across I1 is R1 is I1 and current across R2 is I2, that is electric current varies. That is potential difference is constant in parallel connection, whereas in series the electric current is constant. The combined resistance in parallel connection is given by 1 by Rp is equal to 1 by R1 plus 1 by R2 plus so on plus 1 by Rn. When only two resistors are given, then we can write 1 by Rp is equal to 1 by R1 plus 1 by R2. That is for only two resistors. For only two resistors, this is the form. Now I am taking LCM of the right hand side. What is the LCM on the right hand side? R1 and R2. Here I am multiplying with R2 and here I am multiplying with R1. In the numerator I am be getting R1 plus R2. If I reciprocate it, I'll be getting Rp is equal to R1 into R2 divided by R1 plus R2. See, this formula is going to help us to solve the problems on parallel connection for MCQ, that is Rp is equal to R1 into R2 divided by R1 plus R2. That is the shortcut formula, we can use it. Now let us solve some problems on series and parallel connection of the chapter. Let us solve one problem on calculating the combined resistance. In this problem he had given R1 is equal to 500 ohm and R2 he had given 1 kilo ohm. We know that 1 kilo ohm is equal to 1000 ohm. 1000 ohm. And we know that the effective resistance in a series RS is given as R1 plus R2, and two resistors are given. Here R1 is 500 ohm and R2 is 1000 ohm. When we add them, we will get 1500 ohm, that is RS is equal to 1500 ohm. If we divide it by 1000, we will get 1.5 kilo ohm. Therefore, we can have two values of RS, that is RS is equal to 1500 ohm and RS is equal to 1.5 kilo ohm. Let us move for the next question now. Calculate the combined resistance of the given circuit. Here he had given two resistors R1 and R2. R1 is equal to 2 ohm and R2 is equal to 2 ohm. I need to calculate the combined resistance and they are in parallel. Therefore Rp is equal to question mark, and 1 by Rp is equal to 1 by R1 plus 1 by R2 is the effective resistances in parallel. See here 1 by Rp, and I'm substituting the values of R1 and R2. 1 by 2 plus 1 by 2. What is the LCM here? LCM is 2, and here I need to multiply with 1, and here also I need to multiply with 1. I'll get 1 into 1 plus 1, and we'll get 1 by Rp is equal to 1 plus 1 by 2. Therefore 1 by Rp is equal to, that is 2 by 2. Here 2 will get cancels, and we will get 1 by Rp is equal to 1. If I reciprocate it, I will get 1 ohm as the combined resistance of the given circuit. Let us solve the next problem. Calculate the combined resistance for the given circuit diagram. Here he had given three resistors R1, R2 and R3. R1 is equal to 4 ohm and R2 is equal to 4 ohm and R3 is 3 ohm. He had given R1 and R2 are connected in parallel, and we know that the formula for the parallel connection, that is 1 by Rp is equal to 1 by R1 plus 1 by R2. Now I'll substitute the values for R1 and R2, that is R1 is 4 ohm and R2 is also 4 ohm. What is the LCM here? The LCM is 4. Here I need to multiply with 1, here I need to multiply with 1. So therefore 1 into 1, that is 1, plus 1 into 1, that is 1. Therefore 1 by Rp is equal to 2 divided by 4. So 2 ones are 2 twos are. 1 by Rp is equal to 1 by 2. Therefore 1 by Rp is equal to 1 by 2. If I reciprocate it, Rp is equal to 2 ohm. Now this parallel connection is connected with the R3 in a series. Rp and R3 are connected in series. Therefore, I am using the formula for the series connection. Effective resistance in series. Rs is equal to Rp plus R3. What is the Rp value? That is Rp is 2 ohm and R3 is 3 ohm. Therefore, 5 ohm is the combined resistance for the given circuit diagram. This is the answer for the question. Let us move for the next question. Here the two resistors R1 and R2 are given and they are connected across the two ends of a cell, that is A and B, and the cell is having a potential difference of 24 volt, and he had given the resistor R1 as a 6 ohm, resistor R2 as 4 ohm, and I am rewriting them. R1 is equal to 6 ohm and R2 is equal to 4 ohm, and these two resistors are connected in parallel. What he is asking in the problem, find the current across the each resistor, that is I1 is equal to question mark and I2 is equal to question mark. We know that in parallel current is different but potential difference is constant, and I1 is equal to V by R1 and I2 is equal to V by R2, and therefore I1 is equal to V by R1. I am substituting the value. The potential difference here given 24 volt and the resistance here given 6, and 6 ones are 6 fours are, that is 4 ampere is the current I1, that is, and I2, the current across the resistor VR2 is 24 by, that is 4 ohm, 4 ones are 4 6 are, and therefore the current across the resistor R2 is 6 ampere. Therefore the total current across the circuit is I1 plus I2, that is I1 plus I2 is equal to 4 plus 6, that is 10 ampere is the total current across the circuit, given circuit. Thank you for watching the video. If you like this video, please do subscribe and like the video.